This is a video on solving nonlinear systems of equations graphically. Let's take a look at an example. So here we're given two equations and we need to graph each one of these, and we're going to graph them right on that same set of axes. Let's start with that first equation. Now when we look at this and think about how to graph it, we should notice that there is an x squared. This means we have a quadratic equation. In other words, it's in the form of y equals ax squared plus bx plus c. So in this case, we want to find the vertex, and there's the vertex equation. We can continue by saying x equals, and our negative b would be a negative 2 over 2 times negative 1. I'm using the b and the a. That's negative 2 over negative 2, which equals 1. So that means for my vertex, my x value is a 1. To get the y value, I'm going to take that 1 and put it right back into that original equation here. So I have y equals negative 1 squared plus 2 times 1 plus 3. And that is negative 1 plus 2 plus 3. And that comes out to be a 4. So 1 comma 4 is my vertex. Next, we need the y-intercept. To find that, we'll set x equal to 0, and as you can see, as I just put in 0 for x, I would end up with 3, so my y-intercept is, again, I'm putting in 0 for x, and I would come out with y equals 3. Now for the x-intercepts, we set y equal to 0. In other words, we set this whole equation equal to 0. To solve this, I'm going to divide both sides by negative 1 in order to get positive x squared. This is a quadratic equation. I could use the quadratic formula or completing the square, but in this case I see that I can factor, and if you see that you can factor, go ahead. Factoring is a pretty quick way to solve a quadratic equation. I come down to, well, either x minus 3 is 0, which is x equals 3, or x plus 1 equals 0, which is x equals negative 1. Now those are my x values, but remember we said set y equal to 0, so my x-intercepts are negative 1 comma 0 and 3 comma 0. Those are my x values that I got when I set y equal to 0. So we have our vertex, we have our y-intercept, we have our x-intercepts. Let's talk about how this faces. You look at the leading term, that is the coefficient of the x squared. I can see that's negative, therefore it faces down. And for my axis of symmetry, well, let me do a little graphing first, and then we'll come to the axis of symmetry. Let's put our vertex on first. This is the vertex is at 1, 4, which is right here, and now you can see where my axis of symmetry is. The axis of symmetry is this vertical line which is going right through the vertex. I know that doesn't look very straight, but just imagine that that's a nice vertical line. How are we going to write the equation of a vertical line? That would be x equals 1. And you can see I'm just picking up the x value of the vertex because that's the vertical line that goes through the vertex. Next, let's put in the y-intercept. 0, 3 is right here. And now I can see the cousin point on the other side of the axis of symmetry. Here are my x-intercepts. I have one at negative 1 and the other one is at 3, 0. And from that I can sketch in my parabola. That's a very rough sketch. I'm going to give you a better one in a moment here. There we go. That's the graph of the first equation. I now need to graph my second equation. So here's the second equation. Nothing is squared. This is x to the first power, y to the first power. This is a first degree equation. This is a linear equation. For this equation, I want to be thinking about y equals mx plus b. So I want to solve my new equation for y. Add a negative 2x to both sides. This gives me negative y equals negative 2x plus 1. But I want to solve for a positive y, so I'm going to divide everything here by a negative 1. Get y equals 2x minus 1. We started with 2x minus y equals 1. We transformed that to solve it for y. Now we can go ahead and determine the y-intercept, which would be 0 comma negative 1. We have the slope, which is 2. You may want to write that as 2 over 1. And I can go ahead and graph this now. I'm going to start at my y-intercept, 0, negative 1. and go up 2 and over 1, up 2 and over 1, up 2 and over 1, and this is giving me my new line, which looks something like this. Here's a better looking version. Now we're talking about the solution. Well, the solution is to look at where these graphs intersect each other. So here I can see there's a point that looks like a -2, -5, and this point looks like 2, 3. I'm just going to write that out in a little box here. There we go. There is the solution to our system. Quadratic was not a linear graph, but the line was a linear graph. Our strategy here was to graph both of the equations and to see where they intersect.